All right, so learning Golang Web Dev using the repo at user account goes to 11, Golang Web Dev. Inside, sorry, not prereqs, but inside 0temp, we have 16 SVC where we've done a little coding, several folders in there. If you're just tuning into this on YouTube, follow me on Twitter, as I'm going to be launching something in December. It's allowed me to make about $8,000 to $10,000 a month in passive income. And I want to show people how to do that because I'm pretty stoked about it, that now my wife could be a stay-at-home mom. So follow me on Twitter, and in December when I launch this new deal, which has been making really great money for me, and we'll give people a chance to make money also for themselves. You'll be notified if you're following me on Twitter. So follow me on Twitter. All right. So now what we're going to hopefully get through, I'm giving this presentation live to some people at Silicon Valley Code Camp, is we're going to try to get through understanding templates. We just did a preview of where we're headed with web dev, an introduction to web dev with Go. But now what we're going to work on is we're going to try to get through everything up through 11. And so we're going to look at templates and some of the nuances of templates. And then we're going to get to some hands-on exercises that over lunch, once you've eaten, you can play around with them. So right now, where we're at is right about at 0.2. We have to get up to 0.12. So in the past, I've been live coding. I'm just going to walk you through some stuff that I already have written and show it to you just for time's sake. And then explain it and give you enough information to do the hands-on stuff. So the first thing you need to know is this is a point of confusion for some people. You have godoc.org, and you also have golang.org. And if you go to golang.org, you could go to documents, and then you could go to package documentation. And then down here, you have different package documentation. And so one of the packages you have is text template. And you also have in here the package, just for illustration, the difference between godoc.org and golang.org. You also have fumped. If I go to package fumped at golang.org, I could also go to godoc.org and go to package fumped. And it's the exact same package. It's the package fump from the standard library. So what the fuck is the difference between godoc.org and golang.org? Right? And so golang.org is the official website of the Go programming language, where they have the documentation for the standard library. Godoc.org is a website some dude or dudette put together for package documentation for the Go programming language, the standard library, and third-party packages. So I could go in here and I could say, hey, show me Julian Schmidt's packages. And there's some package that I could use for the Go programming language, not part of the standard library, but it is a Go package which I can import and use that some random guy in Australia wrote, which actually is really awesome. And we're going to see Julian Schmidt's HTTP router when we get down to third-party servmucks. Okay, and we'll learn what servmuxes are. But that's the difference between golang.org, which I am not going to use for documentation, and godoc.org, which has the standard library documentation and third-party documentation. So we were just looking at the FUMP package as an example. We're talking about templates. We have text template, and we also have godoc.org HTML template. What's the difference? Text template is like the base package for defining how templates work. It has no HTML functionality, considerations built into it. Text template is what you would do if you're going to do like a Christmas letter and you just need a template to mail merge to your contacts to put your Christmas letter together. Text template. You want to build a web page? HTML template is built on top of text template. Has everything text template has to offer, plus HTML considerations, context-aware, context-sensitive escaping of HTML so you don't get cross-site scripting, things like that. So if somebody drops into your form field some script tag to launch some malicious cross-site scripting, HTML template has a lot of stuff built in to take care of that. So that's the difference. First thing, text template versus HTML template. So now let's take a look at, I always have this fear because sometimes it happens that I'm not recording. Now let's take a look at some of the basic stuff. And so on this repo, we have understanding templates. We have string to HTML. So understanding templates is going to talk to you a little bit about templates, how templates work. So if you're new to this, you kind of see templates are about merging data. We've covered that already in this class. And then the next one, which is string to HTML, kind of illustrates just this idea of templating, which is merging data with some other text. And so there's just some basic ways we could do that. Here I just have some text, right? I merged some data with it, and then I could print line that to standard out. Or when I ran this, I could use command line arguments. I could print line this to index.html, and it'd create an HTML file. And I could say, hey, look, with just straight programming using Go, we could start to think about what is the task we want to accomplish. As a programmer, how do we accomplish that? We don't need to get Mustache or Angular or Ember or React and have stuff built for us. We can stop and think. And we could say, we need to have some text. We need to merge it with some variable. And then we need to just print that somewhere. Print it to standard out, print it to a file, right? So if I wanted to, right, prints it to the file, or standard out. Or if I wanted to, just standard index, standard command line stuff, printed it to index.html, right? And now there's my HTML page. And okay, so we're pretty close to kind of creating web pages, and we just have to serve that back to a client. And cool, right? So just kind of all right, can we just think about this as programmers and solve the problem? And you could also use some of the stuff that's built in to create operating system. Will create a file. And so create takes a string, gives us a pointer to a file and an error. Right? If we go and we look, so we get that pointer to a new file, that's my identifier. And anytime you open a file, you need to close it, so I'm using the defer keyword. Defer means run this line when this code block exits. So when this code block, this function exits, it will run all of the deferred statements, which means it'll run this one. And it'll close that file which I've opened on your computer. You don't want to keep opening files without closing them. You're going to run out of memory, right? So that's how the defer keyword is used. And so the nice thing about defer is where I open something, I could close it right there, and still use it because this won't run until it exits. But when I'm looking at my code, I could see really clearly this was open, this was closed, good. It's next to each other, nice. And then I could use copy from the input-output package, and I could copy my string, all this stuff, and wrap it in strings new reader, which makes this implement the right reader interface, and I could write it to that new file. Copy takes a reader and a writer, their interfaces, right? Already a file implements the writer interface. I could go look at that so we understand it. This is something it takes people a little bit of time to understand. And so let's just investigate it for a second. So if I go to godoc/io, I can look at the type writer, and I can look at the type reader. And writer is an interface, and you have to have this method to implement that interface. If you have that method, you are also this type. So anything that asks for that type, if you implement this method, you are that type, and you could be used in that situation. Reader has this method. So understanding interfaces and understanding that, understanding the writer interface and the reader interface, and that to implement the writer interface, your type needs to have that method. To implement the reader interface, your type needs to have that method. Then it implements those interfaces implicitly. And you are now also, that type is two types. It's whatever type it was, and it's a type writer, and it's a type reader. Type writer, haha, right? And so when we look at this code, the reason I'm explaining this, OS create gives us a pointer to a file. So if we go and we look at Godoc OS, and we look at the index, and we do OS under type file. We had OS create, which gives us a pointer to a file. And then when we have a pointer to a file, we have all of these methods. This is the receiver, the pointer to a file. Func, receiver, identifier, parameters, returns, parameters, receiver. So this says that if something is of type file, it has all these methods. Look at that method. Where have we seen that before? We saw that method right here. Same method. Read, p, slice of bytes, int error, in, int error. Read, slice of bytes, in, int error. So a file implements the reader interface. Makes sense, doesn't it? You could read a file. You could also write to a file. Write, slice of bytes, int error. A file implements the writer interface, slice of bytes, int error. So a file is anything which is a pointer to a file. That's its type. It's a pointer to a file, which is different than a file. It's a pointer to a file, right? Which means we're passing around the address where a file is stored and not just the file, right? But that is a type. If you have a pointer to a file, you have these methods, and you are, that value of type pointer to a file is also implementing the writer interface, so it's also a type writer. And it's implementing the reader interface, so it's a type reader. So wherever a writer interface is asked for, wherever a type writer is asked for, copy, give me a writer. I'm passing in a file. Okay? A string does not implement automatically. Here we have a string. It's a variable that's just set to a string right there, right? That does not automatically implement the writer or reader interface. It's just a string. But I could go to the strings package. I could use new reader. New reader returns a new reader reading from S, right? And it will give me back that string, but it's now could be read. So it makes it implement the reader interface. So I can say read this string, pass in a reader right here, and write it to that file. I run this, and the name of the file is going to be index.gohtml, just showing you one other way that you could do that thing where you take a different approach to the problem. We're just taking a string, and we're merging it with data. And then previously I did the command line way of write it to this file. Now I used Go to write it to file by creating the file and then copying that string to the file, and it wrote the file. Okay, cool, right? So we're using Go to solve this problem. And then if you wanted to, you could take in args. So instead of just hard coding in the name, when I ran the program, I could pass in OS args 1. 0 is going to be the name of the my first command in the command line. And then 1 is going to be the parameter that I passed in at the command line. So change directories, 03, go run main, Frankenstein, because Halloween's coming up. Go run main, command line objects, ob, exe, Frankenstein, go run main. Let me try go build. Just printed out Frankenstein. Here it gave me the first thing I ran, which is that, run the program. I made it into an executable, so I could just put in the one command, the executable, and then the second one here. That was OSArgs 0, the first arg. Here's OSArgs 1, the second one. I asked those to print out right here. All right, just so you could see OSArgs, so you could take a little bit of input. So just another approach, and just showcasing the language a little bit, and how you could think about this problem. And so when we look at the file for that, close all, tabs to the right. we were looking at string to HTML, and we saw you could concatenate, doing a little bit of a review. You could just do command line pipelining, output to file with that. You could OS create and create a file, and there was the func for it. Func create from package OS, call the function create, gives us a pointer to a file and an error. We could use defer to close that file. We could use IO copy, which takes a writer and a reader. We did strings, new reader, which is this one, to turn that string into a reader. And then we saw that a pointer to a file implements the writer interface, right? Because it had those methods, which, the io.writer and package io.reader, right? Implement. Need for implementation. Does that make sense? Anybody have questions? It's kind of like a first approach. Cool. We're through 0.3. Now we're going to look at 0.4, which is parsing and executing. And so now we have a couple of different functions that we need to learn and things about text template that we need to learn to be able to work with templates well. So if we go to godoc.org, text template, and we go and we look at the index, and this is like index examples. These aren't given a lot of weight graphically. Their level of importance isn't equivalent to the graphical level of importance they've been given. It's easy for developers to overlook these links right up here, but these are super useful. So going straight to examples and looking at how their things are used, or going to the index and seeing the whole index where you can see I have this type, what methods are attached to it, right? Or going and looking at the files that comprise the standard library. So package files, I could see how is the standard library written, and it'll give me examples of the code, of good idiomatic Go code. So I don't know, helper Go. So here are, here's the code that makes up the standard library. So I could see that. So anyhow, I'm going to go straight to the index, and we're going to learn about templates. So we have type template. And so we want to be able to parse templates and execute templates. That's more what I'm looking for. All right, so we have type template. And so under type template, we have parse files and parse glob and new and must. So we're going to learn about all these. But like if you were to call new, you get a pointer to a template. If you were to call parse files, right, you give it file names, you get a pointer to a template and an error. If you call parse glob, you give it a pattern. So if you look up glob, it's like a collection of stuff in Unix type programming, right? And so here is a collection of things. Basically, I'm going to give it a folder name and then some sort of pattern, like this folder /star. Everything in that folder, parse it, right? So I don't have to pass in every single file name. I can just say everything in this folder. These are where all my templates are, /star, parse them all. That's going to give me back a pointer to a template and an error. That pointer to a template, I like to think of that as a bucket into which a whole bunch of templates could be stored. So if in a certain folder I got 3,000 templates stored, it's going to parse them all and store them in that pointer to a template. And that pointer to a template has all these methods. Parse files and parse glob and parse are also there, but execute and execute template. So execute template is going to allow me to say execute it to this writer, standard out, right? os.standardout, or some file, or my HTTP response writer. I'll implement the writer interface. So I could execute it to any of those places, polymorphism, pass in whatever writer I want, execute it to files, execute it to standard out, execute it to an HTTP response writer. Whoa, polymorphism, pretty cool, seeing the power of it. Right? Look at how flexible that code is. Holy cow. One function, and I could write to files, I could write to standard out, I could write to an HTTP response writer. Holy cow. Like, just take a second to think about how clean that is. Isn't that nice? How many people think, well, that's nice? How many people think, yeah, that's run of the mill. Why are you so excited? How many people think that? To a newbie like me, which is crazy, considering like the opportunities that have been given to me, lynda.com, holy shit, are you kidding? Okay, sure, I'll give it a try, right? Advanced web programming at the university level, okay, I'll give it a try, right? To a newbie like me, that seems like, oh, wow, that's great. That's really reusable code. All right, so we could execute it to anything that takes a writer. We pass in the name of the template we want to execute. It's execute this specific motherfucking template. I want this one right here, right? And then we pass in data. And empty interface, we've learned what an interface is. It defines behavior. We've seen interfaces that define behavior. We did human, and you have to have the method speak to be a human, right? Maybe in terms of accessibility, that's not such a kind, accessible, considerate, aware way to write our programming, because there's some humans that can't speak, and they'd be like, right? You'd be like, what? Right? But an empty interface, everything has no methods, at least. So everything implements that. Every type implements that. So that's basically saying you could pass any type in here of data and then an error. So basically what we're going to use is parse glob. Give me all the templates in this folder. Execute this specific template. That's what we're using. Okay? So what's this other stuff? Well, if you just wanted to run execute, you only have one template and your pointer to a template, it's going to run that one. You got 1,000 in there, or 10,000, or 10 million, it's going to run the first one it finds. What's the first one it finds? Who knows? There's some method to the madness. You could go figure it out. I think it's the alphabetical first one in the list, or it might be the first one it parsed in your folder structure, whatever. It's the first one. Not super flexible, not super useful. That's why you're using parse glob and execute template. All right, so we get all of our templates parsed in a bucket, my word. That's a pointer to a template, and then we execute the template. Okay? So why do we have parse files, parse glob up here, and parse files and parse glob down here? Well, when I get my template, my bucket holding all my templates, let's say later in the program I got to parse in a few more into that bucket. Okay, well here's my pointer to a template. I'm going to parse a few more into that one, right? Or I'm going to parse a whole new folder into that one. Yeah.
You do your buckets inside a bucket and have it point to a specific bucket to do and call it something.
Yeah, but you wouldn't want to. Just store them all in one. Or maybe you can't. I don't know. I've never tried it, but you could probably figure it out, but don't. Have a template holding templates, pointer to a template. Probably not. Probably not. Because template doesn't take a pointer to a template, it takes some sort of strings, right? And that's going to be a file. So we have parse files, parse glob, parse files, parse glob. You understand the difference between these two and this two? Yes? Anybody have questions about that? We have execute and execute template. You understand the difference between these two? Anybody have questions about that? So we're going to use parse glob, execute template, and then the next thing you need to know is must. Well, look at what parse glob returns. A pointer to a template and an error. Look at what must requires. A pointer to a template and an error. So we could take parse glob, stick it right here, and execute it. It'll execute. It'll return a pointer to a template and an error, which must will then use as its arguments, and it'll give us back a pointer to a template. What does must do? Must is just a little wrapper function that makes things a little bit more convenient, so we don't have to check for the error. It does it for us. Right? It just says, hey, if there's an error, just shut this program down. And if not, return that pointer to a template. Okay? So when you see must being used, that's what happens with must. I just closed my documentation. So Godoc text template, we were looking at the index, and we were looking at the template stuff. So type template is just going to be all your templates. Anybody have questions about any of this? In the examples, you'll see new being used. All right, so we can look at the examples, new, template, so here's template must, right? And then template new. Template new is going to give us a new pointer to a template, and then it's going to parse, so off that pointer to a template, parse letter. Letter is this string right here. So that's the template that got parsed in there. When we do parse, parse is going to give us back a pointer to a template and an error, which must requires pointer to a template and an error. right? And so that right here gave us back a pointer to a template and an error. Must does it. We have our template, and then we come down here, and they're just doing template execute to standard out, right? And we're ranging over recipients. So the data that got passed in, the recipients are a struct, right? Recipient is a struct, and then we have a slice of recipient. And we're ranging over recipients, so you could range over data structures. And when you range over a slice, you get back the index and the value. Slice has an index position and a value. And by the way, somebody asked me about the difference between a slice and an array on a break, and I never answered that question, I'm just realizing. So we don't really use arrays in Go. Arrays are more for building the program and used in the background. They're not dynamic. You have to set their size. They're always only that size. A slice will grow automatically. Beneath a slice, underlying a slice, is an array. So a slice points to some array. So a slice is a pointer. So when you pass around a slice, you don't have to take its address. It already is a pointer. It points to 3 data types. It points to the underlying array. It points to a length and a capacity. The length is the length of the slice. The capacity is the length of the underlying array. So if I create a slice, a little bit of a tangent here. So there's other ways that you could create a slice. I could say my slice of string is equal to make a slice of string and a 0 length and a capacity of 10. And then I could do XS is equal to append XS XS is equal to append XS format.println XS. And I could also do this. Dang it, I always try to use my command line or my editor commands. I could see the length and capacity. So now my length of my slice is 2. The underlying array is still 10. If my underlying array was 3, you can see my length was 2, the underlying array, the capacity was 3. My length went up to 4, the underlying array went up to 6. So the underlying array, when I went past its capacity, because the array is only a certain size, they had to copy all the values out of that array into a new one, which is twice the size. This all happens in the background at runtime. And then, copied all the values into the new array, threw away the old array. New array is twice the size of the old one that's underlying the slice. Okay? Anyhow, that's that. So that's length and capacity. So let's see how that works. We just looked at string HTML. So parse and execute to standard out. So here we go. Template parse files, execute, right? And I get back a variable pointer to a template. I check the error, and then I execute it to standard out, because I can write to that. I check the error. One example. The next one is template parse files, just passing in one file name, get my template, create a file, and then execute to that new file. Execute template to that new file, passing in no data. All right. Here I'm parsing files. Template parse files. I just parse one GMAO. I could call these things anything I want. Nothing magical about Go HTML. right? And I execute that one, and then I call from that pointer to a template type. So variable with a value that's type pointer to a template, from package template pointer to a template. I call parse files, no longer from package template parse files, which would give me a new pointer to a template, but from that pointer to a template, I call parse files, parse in the next two files, and then I could execute template each specific one, passing in no data to standard out, right? And then just call and execute again to see which it gives me if I don't specify which template. And then instead of doing all that rigmarole of putting in all the file names, I could do parse glob, and I could say, hey, in the templates folder, parse everything, and if I want, I could say with this file extension, or I could just have it be like this, okay? And just everything that's in there. And so it parses everything that's in there, and then executes each specific one, or this shows you what happens if you just call execute. I think if you just call execute, one GMA is the first O is the first one that comes out. I'm going a little quick just because I want to get you on those examples by lunch. And then here's using must, right? So template parse glob, templates everything in that folder that has this extension. Parse glob gives me back a pointer to a template and an error. Must takes a pointer to a template and an error. So I can say must. I no longer have to handle the error. So I just assign that to TPL, right? I've declared TPL is up here from package template, type template. So this is a pointer to type template from package template. I declared the type of this variable that it will hold. Here I signed it. I declared it up here so that its scope is package level. So the scope is no longer in a function, which allows me to use init. Init is a special function that runs when you initialize your application. When you first run your application, init runs once. You can have as many inits as you want across many different files and many different packages, right? It runs once, and all of them will run after the variables have all been initialized, right? So if I don't want to have a program where every time somebody comes to it, I'm parsing my files. I don't want a server that every time somebody makes a request to my server, I parse 3,000 files. When I boot up my server, when it initializes, parse all the files, put them in memory, get them ready to use. Every time somebody comes to my server after that, they're there, they're ready to use, they don't have to be parsed again. So init is for like setup. So I'm going to parse all my files in the setup, store them in TPL, which is at the package levels, so I can now access it down here in main. Execute template. Questions? Too fast? Raise your hand. Okay. Good exposure. So that's parse files. I can now pass in data to my templates. So we saw this in the preview. Execute template takes a writer, the template, and a piece of data. So here's my TPL. Then I template, parse files, or glob, whichever, and then must, store it in TPL, and then execute my template. What we are doing is parse templates, execute templates. This is conceptually the two steps that we're learning to work with templates. Notice we are working with text template. Later we'll change this to HTML template, and that's all we changed to make it HTML safe, right? So that's passing in data. We can also pass in variables. And so like if I pass in release self focus, embrace other focus, just a string, I'm just passing in a string. I think that's like the meaning of life. And my template is the meaning of life. So I could take the data that comes in. The data comes in is assigned to dot. That's your current piece of data that you pass in. And we'll learn more about that in just a second. If I take what was there, and then I could just say, you know what, I'm going to create a variable. So I put a $, kind of PHP-esque, and then the variable name, and I say short declaration operator, this variable is now equal to that, and so then I could use that variable on this template. So if you ever need to like create variables to use somewhere else as you kind of go range over data or something, you could do that. So that's just showing how to use a variable in a template. And then data structures, and maybe we're getting close to a point, right? So here I'm just kind of reviewing like data structures. Let me just see, how do I pass different data structures in to my templates? And then how do I do that and assign it to a variable? And so here I have a slice of string. I'm passing in a slice of string. Slice of string. Pass that in. And in my template, I could range over the current piece of data, which is a slice of string. When I range over a current piece of data, it's like a pipeline. The output of this becomes the input of that. So if I range over that, each iteration of a slice of string is going to be a value, which is a string. So print out that string. So that's how that works in the notation, slice of string. With a map, as I range over a map, right, same thing, pass that in. Here's the current value of the map. So pass out the current value of the map. And with a struct, here's my struct, name and motto. If I want, I could just do a name and a motto, right? Get each field. So I'm only passing in one instance of Buddha is of type sage. I could pass in a slice of sages. Right? So Buddha, Gandhi, MLK, Jesus, Muhammad, I went overkill. Give me a slice of those sages. Pass in that slice. Passing in my sages. The TPL, range over that slice. Okay, each iteration of that's going to give me a sage. And a sage is a struct with a name field and a motto field. And I could do stuff like this, where I have sages, I have a sage, I have a car, and then I have items. Right? So items will be a slice of sage, and cars will be a slice of car. Transport will be a slice of car. Right? So I could create my sages, I could create my cars, I could get a slice of sage and a slice of car, I could create an instance of data, which is items, wisdom is a slice of sage, transport's a slice of car, pass that data in, and then here, I could range over wisdom, I could range over transport. Those are each of the fields of the struct that came in, right? And I could, each time I get here a sage. Each time I get here a car. So that's really one of the things that people who are new to kind of like using Go, it seems like the students kind of take some time with that. How many people speed's okay? Of this? Cool, because I think we got like 5 more minutes and then lunch and then some hands-on. We could start a little bit late, coming back at 1. So then we could also use functions. We could pass functions. Now, from an MVC, separation of concerns, right? However you want to think about it, because MVC is actually another way of is a implementation of separation of concerns. And basically, you want to have, like with separation of concerns, your processing should happen on the server. Like that would be your controller. And then your view, that's what the user sees. So all your view code, that's the view. You shouldn't be like processing in that. That should be in the controller area. And then your models, all the data code, And so when we have a func, right, that's starting to put some processing into the view. But sometimes maybe you want to do a little of that, and that capability is here in Go. And so you could, to pass functions that you could use in your templates, you have to create a func map. So this is any identifier, but it needs to be from template. You need to create a func map, and that func map is a struct. So here we have a composite literal, right? And so template func map, if we go look at that, a func map is a map string interface, and then we put in the values. And so here we have UC. I create the map value, and then here's the key, right? And then here we have FT, and then here's key. I said this is a struct. It's a map, all right? So there's the key and the value, the key and the value, and what I'm passing in is this function, which will be available in my template, is just coming from the strings package, and it's the toUpper. Make this text toUpper. This function is coming from right here. I just created it. It takes a string and it returns a string, trims the space, and then it'll slice the string and it'll give me from the start of the string up to, but not including, the fourth character. All right, so 0, 1, 2 of that string, those characters, and then it returns that. So then I pass in all of my data, and then on here I could call range over wisdom and make everything uppercase. Right? Or I could use this. Here's another one. Give me the index position 0 from wisdom and that person's name. So I could. This is a built-in function. Or here, ft kind of trimmed my string, and I'm asking from index that which is at slice position 0 from this piece of data, right? On the name, I want you to just give me the first part of it. So it gets a little bit tricky, a little bit nuanced, takes a little time to get used to it. So we have both our custom functions that we could build with our func map, and then also we have global functions. And when to get the functions connected, you have to do, and I know this is a little bit like fast, but you do a template, and then you add func map to it, and then you parse your files. So that's the code pathway. You can come back to it. I'm not going to ask you all to do that. This is just FYI for you to revisit at your own time. And then predefined global functions, it breaks it out and shows you how to use index comparison. If we look at the code on that, 09, I know this is a little bit quick, but I want to get to lunch. 09, right, global functions. We could read about functions here. And so here in text template from the standard library, talks about the global predefined functions. And you saw me using index to access the index of a certain position, right? And there's other ones you could use there. So that's where if you want to do a little quality testing on your template between data and things like that, you could do that. And then nested templates. This is super important. Lunch is calling, break's calling, you're fatigued. Focus in for 2 more last minutes, and then we are at the hands-on portion, right? But nested templates allow you to do things like this, where I say define polar bear end, right? So I could have a file, and instead of calling something by the file name, I could just define templates, and then on another one, I could use that template. So I defined polar bear, and I used template polar bear. So you could start to see, okay, well, let me define this stuff as header. Let me define this stuff as footer, right? And then I could, I don't know if I do that in here. Here, let me close all these. Here I define header. Here I define below the fold area. Here I define index. And I didn't define footer, so I'm going to extract that out. Template footer, because it seems logical to me. And so I could put this in a new file, footer stuff.gohtml. I'm calling it footer stuff, and I'm going to rename this one to header stuff. Just to illustrate, we're not calling the file name, but now I'm going to define footer, right? That's where the template's being defined. Another way to kind of, and then I end, and then I put the footer in there. And so now this footer stuff, split horizontally, and this header stuff, I define header, in header, define footer, in footer, and then I use that on, and define below the fold, right? I use that up on main, my index.gohtml, and I can say, hey, bring in all my SVGs. I also have my SVGs defined. All right, so here's an SVG defined. So I can say, bring in all my SVGs. Bring in my header. Right? Here's the main body of the page above the fold. Here's the below the fold stuff. Now bring in my footer. Now when I run this, 0, 10, 4, I go to localhost. And this is all above the fold. There's the below the fold. It's like really good, performant, light, lean, no jQuery, no boot crap, right? No JavaScript, beautiful, not downloading font awesome, which is 98 kilobytes. I extracted the font I wanted, and I'm using that as pure code, baby. And this is like less than a kilobyte right there. And now I'm going to be super fast and super beautiful. No matter what screen size you look at this, that SVG is going to be nice. This is how you build it. It's the best way to build it today. That's awesome, right? Whoa, I love that so much. But we've modularized our code, defined templates, put those templates, nested templates in other templates using this define footer, define header, define BTF, you know? And so now we just need to start using that. I love, love, love this example. And I called it preview because we haven't learned about this. We've previewed it once. We're previewing it again. After lunch, we're going to understand servers, TCP servers, HTTP servers, listen and serve, serve mucks, third-party serve mucks, and then handle func and handler func. We're going to understand all that after lunch. Then we'll have some more hands-on things. But the hands-on stuff that I want you to look at during lunch is this just talks about composition, which we covered already. And then here, these hands-ons ask you to pass different data structures into templates. So it's really about how do I build my data, because I get to pass one identifier into my template. So I'm probably going to use a struct, that composite data type, which will have fields, and then I'll be able to access those fields, first name, last name, slice of sages, range over them, right? I'll be able to access those fields and use that data on my template. So those are the hands-on challenges. So how many people for 3 hours, 9 to noon, 15 minutes of which was I was just telling you about my life, how many people is like, this was the best thing ever? Best thing ever? Raise your hand. How many people like, this was pretty good? How many people you're like, oh, I'm liking Go? Okay. How many people are hungry? Let's go eat.